So now that we have a nice infrastructure in place for our weapon system, let us turn our attention back to enemies. At this point, we have one enemy within Spacefighter, and that is an asteroid. The asteroid, believe it or not, can take advantage of weapons because asteroid extends enemy, which extends ships, so it has a fire action and it has a weapon field, but it wouldn't make a lot of sense for us to put weapons on the asteroid, though we could, which is pretty cool. In this case, it would be nice if we had an enemy ship on the screen. So between this video and the next video, we're going to look at and then create an enemy interceptor, which from this point forward in this video I shall simply refer to as an enemy. Okay, so our enemy, being an enemy ship, is going to be a very straightforward class. There's no complicated code within it. There's nothing new. Everything that Logan's going to type is code that you've seen before. The primary focus of Spacefighter is to introduce you to the Spacefighter style engine and to talk about the creation of this engine. It's not to spend time on artificial intelligence for enemies that are running around trying to kill our players. We'll be taking a look at artificial intelligence in later XNA courses. So there are a few considerations, the very first one, of course, being AI. How are we going to handle the AI when we begin coding the enemy class? Well, it's going to be very straightforward AI. It's going to look kind of like this. The enemy is going to move down the screen. Though we couldn't leave it that basic, what we've decided to do is add some very simple avoidance code into the AI system for our enemy, if you will, so that the enemy tries to avoid players. Now, let me give you just a very quick sneak peek as to what it's going to look like when the coding process begins for the avoidance system. It's very straightforward. This is a player ship. It is moving up the screen. This will be an enemy ship that is moving down our screen. What we're going to do is set up a configurable radius for our player ship. So let's just draw that real quick. And just believe me when I say that's a radius, even if it does look horrible. All right, so here we are with a radius, and if an enemy finds itself within this radius, then it is going to try to avoid our player. Now, how are we going to go about calculating where the enemy needs to move so that it looks as if it is trying to avoid our player? Well, we have vectors that we can work with. We know which way he's traveling. We know which way the player's traveling. And we can subtract the player's position away from our enemy's position, and we can come up with this information right here as well. So we can come up with that vector. And then we can normalize that vector. And we can use that for determining a new direction for our enemy. So the formula that we're going to end up using is going to look kind of like this. We're going to normalize our enemy's position minus our ship's position. Hope you guys are enjoying the symbols that I am using for the math here. That works for me, so I don't have to do a lot of writing. And that is going to give us a normalized vector pointing from our ship towards our enemy ship. Now, with that in place, let's take a closer look at our enemy. So here we are with our enemy, and we have that vector that we can work with, and we've now established this vector that we can work with. What we're going to do is we're going to come up with a new vector that is a blend somewhere between the original downwards direction that our ship is going and this new vector that we've just generated. And we're going to establish a weighting parameter that we can use to determine if we are weighted more towards going down or more towards going in the direction of this new vector. So if we had set a weight value of 0, we would be going down, meaning we're not weighting ourselves any towards this new vector. If we had a weight value of 1, we would then be weighted all the way back towards this new vector. So any value in between, with 0.5 being something like that, you can see the range of motion that we could come up with, or let me say the range of new direction that we could come up with. So what we're going to end up doing is biasing it just slightly off 0, so we'll just end up going something like that. But if we were to change our direction to that, even this is going to make it appear to a player that the enemy is like, let me get away from the player's ship. So he's now trying to move over to the side, so he's no longer moving straight down. So that is our only form of AI that we will be using for the enemy. We had to throw something in there. Just going straight down looked kind of boring. So this does make things just a little bit more interesting. Like I said, we will be revisiting artificial intelligence in the future in a course that is specific for AI within XNA. From there, the next thing that I want to talk about, a consideration, is who's firing. We know that we have this fairly robust weapon system, and we know that the weapon system has been designed in such a way that a player, meaning myself or Logan, playing the game hits the fire button on the controller, and that ends up causing a chain reaction of events to occur that causes a fire to happen. In the end, that fire action to get invoked on that particular ship. But as far as an enemy is concerned, who's hitting the fire button? I mean, these enemies, it's just code. It's just an instantiation that's taken place, and he's running down the screen, but who's controlling him? Again, the AI is simple, but somebody's got to hit the fire button. Well, we're going to establish a timer, and the timer will simply be responsible for hitting that fire button. So not a very complex system, once again, but there's some things that we'll need to consider. You don't want because obviously we're starting off with our enemy slightly off screen so that he nice and neatly scrolls down onto screen, but we don't want him to begin firing with him off screen because that would look kind of odd with projectiles suddenly coming on the screen. So that's something we'll have to take into consideration when we begin creating the class. So who's firing? A timer is going to be firing. Next question is going to be, who are we firing at? And those of you watching the video may have quickly jumped on that and said, well, that's pretty straightforward. The player. Well, we've already established the fact that Spacefighter will support multiple players. And if we support multiple players, it would be very unfair if the enemy or all enemies were firing only at one player. Let's say player 0. That wouldn't look good. So we need for some way for an enemy to select different players. And the way we're going to go about doing this is we are going to revisit game node. And back up on game node, we're going to add a new piece of functionality, a new method called pick random node. And pick random node will allow us to basically specify a specific list that we would like for a random node to be given back to us out of. So we know that we're maintaining a players list, we're maintaining an enemies list. Wouldn't it be nice if we had, let's say, 3 players, if we had some sort of functionality in place that could say, here, take this list, a list of players, and in that list, grab a node, well, let's just pick this guy right here, and give it back to us. Then back over an enemy, that enemy can store the return node in a target. Now, we have something to aim our weapons at, and we have someone to hit the fire button. So now we can fire, but that brings up the next consideration, and that is, what weapon do we have? Well, if you recall, I already said that we have ship, and from ship, we had enemy, and from enemy, we had asteroid, and we're going to have our enemy interceptor. The bottom line is this guy is a ship. Since he is a ship, he has a weapon field, and he has that fire action delegate. So we can give this guy the weapons that we've already designed in our weapon system. So we're going to do that. As a matter of fact, we're going to give this guy a burst weapon. Though the weapon system, as far as the ship is concerned, is a 2-part thing. The first part is what weapon are we going to use, and that determines our timing as well as direction. But we also need to take into consideration fire action. And so you may be thinking to yourself, well, we know we've created bullet, and coming up soon we'll create missile, so we can just give the bullet right now over to this guy and all will be good. And not necessarily. If you think back to when we were working with projectiles and we created the bullet and we started talking about collision lists and all that good stuff, those bullets were more concerned with colliding with enemies as opposed to colliding with players. So I guess what I'm getting at is our projectiles have been tailored more towards player projectiles as opposed to enemy projectiles. So that's something that we're going to need to take into consideration. Now, again, these videos are about the creation of the Space Fighter engine. I don't want for Logan to go in there and start redesigning projectile to start taking into account, is this a player, is this an enemy? I like it the way that it is at the moment. We could easily go and extend projectile into an enemy bullet, but you guys know how to do that. And at that point, there's nothing new to gain from a video lecture over that. So what Logan's going to do is simply embed the spawning code, the code necessary for spawning projectiles into a method inside of the enemy itself, as opposed to referencing a projectile class. And here's the neat thing. That's actually very cool. It's nice that we have the ability to just slap a set of instructions into fire action as opposed to being forced into going over and creating a new class that has to extend projectile. We have that flexibility right at our fingertips. So in this particular case, since there's nothing new to gain out of a video over making a new projectile that does the exact same thing or almost the exact same thing as the player's projectile, let's just embed it right here because we can do that. Let's see. Outside of that, anything else? Looking over at my notes quickly, I think that's everything I wanted to talk about. Again, like I said, the code is really straightforward. There's just going to be a lot of it because there's a lot of configuration stuff that we need to get down. The only big thing that's going to be of interest is when we revisit game node and we set up a method in game node that allows us to pick a random node out of a given list and return that back to whoever the caller was, and then a little bit of avoidance code that we're going to use to come up with a new direction for our enemy so that it looks as if the enemy is trying to avoid our player. There's not a lot of emphasis on the enemy code here. We want something simple that can make use of our weapon system and fire at our player, but something that we can fire at as well. Logan, is there anything you'd like to add to this?
No, I think that wraps it up really well. Again, it's going to be just a few major subsystems that we're going to address that allow the enemy to avoid players, that allows him to target players and aim his weapon at them, and then the firing system with the new projectile that he'll be firing.
Exactly. All right, guys. Well, with that, that's going to wrap up this video, and in the next video, Logan shall begin and complete coding the enemy Interceptor class. Thanks a lot.